Recall that the series a sub n times x minus c to the n equals a sub 0 plus a sub 1 times x minus c plus the rest of this is a power series centered at c, where c is a constant. If we're going to center this at anything other than 0, we're going to need the x minus c. If we were centered at 3, all of these would be x minus 3's. For a power series centered at c, precisely one of the following is true. 1. The series converges only at c. 2. The series converges for all of x. And 3. There exists a radius of convergence greater than 0, such that the series converges for the absolute value of x minus c less than r, and diverges for the absolute value of x minus c greater than r. R is called the radius of convergence of the power series, and in part 1 the radius is 0 because it only converges at one value. In part 2, the radius of convergence is infinity because it converges for all values of x. The corresponding domain is called the interval of convergence. We have our first example, example A. Find the radius of convergence and the interval of convergence for the following. We have for n equals 1 to infinity of negative 1 to the n plus 1 times x minus 5 to the n over n times 2 to the n. We're trying to find the radius of convergence. So we'll see, we'll do the ratio test to find out what's left after we divide this term by its previous term. So we have the limit as n approaches infinity of the absolute value of negative 1 raised to the, if n is going to change to n plus 1, this will be n plus 2. We have x minus 5 raised to the n plus 1 all over n plus 1 times 2 to the n plus 1. Now we're going to multiply, or we're going to divide by the n plus the nth term, so we can multiply by the reciprocal. We have n times 2 to the n over negative 1 to the n plus 1, and then times x minus 5 to the nth. Let's start canceling stuff out. We have negative 1 to the n plus 2 over negative 1. We have an extra negative 1 on top. We have limit as n approaches infinity of the absolute value of an extra 1 on top. That cancels those out. How about the x minus 5s? We have an extra x minus 5 on top. Is there anything else extra? We got those right there. We have an n and an n plus 1. Those don't cancel out. An n and an n plus 1. So I took care of those. And there's an extra 2 in the denominator. So we have a 2 down here. That's equal to the limit as n approaches infinity of, we have negative n over n plus 1. And we could probably put the 2 down here with this. So we have a 2 times the limit as n approaches infinity of x minus 5. And we have the absolute value of that also. Now we can write the limit as n approaches infinity of absolute value of negative 1/2 times x minus 5. This will converge as long as the absolute value of negative 1/2 times x minus 5 is less than 1. X minus 5 is less than 1. Now if we use the definition of absolute value, we have negative 1 is less than negative 1/2 times x minus 5 is less than 1. Multiply both sides by negative 2. We have negative 2 is less than x minus 5 is less than 2. And if we add 5, we have 3 is less than x is less than 7. And we're asked for the radius of convergence and the interval of convergence. Our interval of convergence is 3 to 7. And our radius of convergence, let's look at a number line here. If we have 7 and we have 3, if we add these two together and divide by 2, we get 5. The interval, the radius of convergence is 2 units. Our next example, we have n equals 0 to infinity of x over 3 to the n. And this is geometric. The absolute value of x over 3 has to be less than 1. That's what our r is. We have -1 less than x is less than over 3 is less than 1. We have -3 is less than x is less than 3. Our interval of convergence is -3 to 3, and our radius of convergence is 3. Letter C, we have the limit as n approaches infinity, the absolute value of -1 to the n plus 1, x to the, that'll be 2n plus 2, so we have 2n plus 3 over 2n plus 3 factorial. And we'll divide that by the nth term, or multiply by the reciprocal. We have 2n plus 1 factorial over -1 to the n, x to the 2n plus 1. We have the limit as n approaches infinity. Let's see, we have an extra -1 on top. That takes care of that. We have 2 extra x's on top, so that makes that x squared. And on the top, we have 2n plus 1 factorial. And in the bottom, we have 2n plus 1 factorial times 2n plus 2 times 2n plus 3. And we have the limit as n approaches infinity of, the factorials will cancel out, and we have negative x squared over 2n plus 2 times 2n plus 3. That's equal to the limit as n approaches infinity of the absolute value of -1 over 2n plus 2 times 2n plus 3 times the limit as n approaches infinity of the absolute value of x squared. And we don't really need the absolute value on that one. That's equal to 0. If we plug infinity into the denominator goes to infinity, and this fraction goes to 0, times x squared. We need this to be less than 1. This is always going to be less than 1. The interval of convergence is -infinity to infinity, or all reals, and the radius of convergence is infinity. We have the limit as n approaches infinity of the absolute value of n plus 1 factorial times x minus 3 to the n plus 1 over n factorial times x minus 3 to the n. That's equal to the limit as n approaches infinity of this right here. It can be n factorial times n plus 1. We can factor out or cancel out the n factorials. This will be n plus 1. There's an extra x minus 3 on the top, and on the top we'll have that extra x minus 3. This is equal to the limit as n approaches infinity of n plus 1, and then times limit as n approaches infinity of x minus 3. As n goes to infinity, this is going to go to infinity also. We have infinity times x minus 3. Now this will be less than 1 as long as x minus 3 is equal to 0. X is equal to 3. This converges only on the value 3. The interval of convergence is 3, and the radius of convergence is 0.